Chapter 4. Atmosphere. We breathe in air with oxygen. We can't live without it. When we breathe out, we give out carbon dioxide. Also, atmosphere makes life possible due to other reasons too. For example, it prevents harmful rays of the sun from reaching us. Green plants take in carbon dioxide, use sunlight and water to photosynthesize, and we end up getting delicious fruits, vegetables, grains, etc. from them. These give us proteins, carbohydrates, sugars, fats, minerals, and other nutrients that we need to live. It is the atmospheric winds which transport water from the oceans deep into the continents in the form of rain. The atmosphere is a sea of gases surrounding Earth. When we compare the size of Earth, the atmosphere is a very thin blanket surrounding Earth. The atmosphere is about 1000 kilometers thick. Being composed of gases, the atmosphere exhibits all the properties of gases. It compresses and expands, and it has no shape. There are many gases in the atmosphere, but oxygen, about 21% by volume, and nitrogen, about 78% by volume, dominate. Other gases are in very small percentages. These include argon, neon, carbon dioxide, methane, ammonia, ozone, etc. Water vapor accounts for about 0.4% by volume over the whole atmosphere, but most of it close to the surface. Apart from these gases, the atmosphere also has fine dust particles. These are called particulates. These particulates can change atmospheric conditions that may be beneficial to life on Earth. The particulates also can cause problems by altering temperature and rainfall patterns. For example, they can make it difficult for people to breathe. They can settle on leaves and make it difficult for plants to breathe and photosynthesize. Structure of the atmosphere. Just like the interior of the Earth is arranged as layers, atmosphere too is arranged in various layers, having different compositions. On the basis of chemical composition, the atmosphere is divided into two broad layers. 1. Homosphere. 2. Heterosphere. Homosphere. The homosphere extends up to a height of 90 kilometers. It consists of three layers: troposphere, stratosphere, mesosphere. Heterosphere. The layer about 90 kilometers of the atmosphere is called heterosphere. It has two layers called thermosphere and exosphere. 1. Troposphere. The troposphere is the lowermost layer of the atmosphere. Its average height is 13 kilometers and extends roughly to a height of 8 kilometers near the poles and about 18 kilometers at the equator. Thickness of the troposphere is greatest at the equator because heat is transported to great heights by strong convectional currents. It contains about 75% of the total gaseous mass of the atmosphere and practically all the moisture and dust particles. The entire weather phenomenon happens in this sphere. Stratosphere. This layer extends up to a height of 50 kilometers. This layer is almost free from clouds and associated weather phenomenon, making conditions most ideal for flying jet aircraft. 3. Mesosphere. It extends up to a height of 80 kilometers. Meteorites burn up in this layer on entering from the space. thermosphere. It extends up to 400 kilometers. In thermosphere, temperature rises rapidly with increase in height. It contains electrically charged particles known as ions. Pressure belts and planetary winds. Air pressure. Thus, air exerts pressure not only from the top but also from the bottom and the sides of an object if it is exposed to air on those sides. Pressure belts. Winds are moving all around the world. At the equator, the high temperature heats up the atmosphere and the hot air rises, creating low pressure at the Earth's surface around the equator. This low pressure belt is called equatorial low pressure belt or the intertropical convergence zone. As this air rises, it cools and starts descending, but it cannot come back in the same path that it took when it went up. As it reaches the upper heights of the atmosphere, the air spreads away from the equatorial region towards northern and southern hemisphere. As it spreads, it also starts descending. It is cooler, denser, and so starts to sink back to Earth. Where it descends, we find the pressure is higher is called subtropical high pressure belt. Having come down, as the air hits Earth's surface, it splits into two parts. One part again rushes towards the equatorial low pressure area. When they get there, they get heated again and rise. Thus, the equatorial cycling of wind continues. Classification of winds. Depending upon the wind speed, their features, their directions, the way they occur, winds are classified into three types. A. Planetary winds. The winds that blow continuously and regularly above the world pressure belts are known as planetary winds. These are of three types: trade winds, westerlies, and polar winds. Trade winds in the tropics, westerlies in the temperate belt, polar winds in the polar belt. Trade winds are easterly in direction if that moving from east to west. They are northeast trades in southern hemisphere and southeast trades in southern hemisphere. Westerlies, on the other hand, blow from west to east. That's why they are called westerlies. They are southwest in northern hemisphere and northwest in southern hemisphere. Polar regions experience once again easterlies. Effects of planetary winds. These winds play a crucial role of transporting heat and moisture across the world. That is why no part of the world gets too cold or too hot for life to survive. B. Seasonal winds. The rainfall which occurs in India is mainly due to seasonal winds. All factors in the country are related to monsoons. Monsoon is derived from Arabic word mosam. Existence of monsoon is due to differential cooling of land and sea. Summer monsoon develops over northwestern India, while southeast trades cross the equator. As a result of Coriolis effect, it becomes southwest monsoon over peninsular India and adjacent countries. In winter, reversal of pressure belts if that northeast trade winds cross the equator. As a result of Coriolis effect, it becomes northwest monsoon over the northeast Australia. Local winds. The local winds blow due to local variation in the temperature and pressure and influence a very small area. Hot local winds raise the temperature of the area. Cold local winds sometimes bring the temperature to the affected area below the freezing points. These local winds blow in the lower area of the troposphere. Weather and climate. This mixture of gases and particulates that we call the atmosphere is not sitting still. It is very dynamic. It moves up and down and horizontally in all directions. As it does this, its characteristics change. It may get warmer or cooler, wet or drier, etc. When we describe the condition of the atmosphere for a small period of time, usually about 10 days at most, weather can change daily, even within a day. How do we describe atmosphere? We use temperature, pressure, wind, humidity and precipitation. These are called the elements of weather. We use these to describe climate also, as we'll see soon. So these are also elements of climate. You have just learned about pressures and winds above. Temperature. On Earth's surface, as you go higher in altitude, the temperatures decrease. Climate is a description of the average atmospheric conditions for areas over a long period of time. Climatic descriptions are based on decades of atmospheric data and finding the averages of them. Climate descriptions tell us what conditions are for a given time of year, but not on specific days. Humidity and precipitation. The moisture in the atmosphere is derived from water bodies through evaporation and from plants through transpiration. Humidity is the amount of water vapor in the air. In high humidity, our sweat doesn't cool us because it cannot evaporate. In low humidity, we also feel more thirsty. We express humidity not directly, but using the concept of relative humidity. Relative humidity is the ratio between two things. 1. The maximum water vapor that the air can hold at a given temperature and pressure. And 2. The actual amount of water vapor it holds at any given time. Condensation. Condensation is the opposite of evaporation, as it involves conversion of water vapor into droplets of water or crystal of ice. When the relative humidity exceeds 100%, the excess of water vapor present in the atmosphere gets condensed as minute droplets of water. The dust particles attract water molecules from the water vapor in the atmosphere. This causes condensation of the vapor into droplets. Millions and millions of these droplets together appear at different kinds of clouds. With condensation, the droplets get heavy and fall to earth as precipitation in the form of rain, snow, hail, etc. Forms of precipitation. Rainfall is the most common form of precipitation. When condensation takes place at temperature below freezing point, water vapor condenses directly into ice crystals. These may fall down on the earth as powdery mass or flakes of snow. This form of precipitation is called snowfall. Snowfall is quite common in middle and high latitudes and mountain regions. When rain falls through a cold layer of air near the Earth's surface, raindrops get frozen into ice and fall down. This form of precipitation is called sleet. Types of rainfall. On the basis of origin, rainfall may be classified into three main types. Convectional rainfall. This type of rainfall occurs when moist air over the heated ground becomes warmer than the surrounding air and is forced to rise, expand, cool, and yield some of its moisture. Conventional rainfall is common in low latitudes and on summer days in interior part of the continent. Orographic rainfall. Orographic rainfall is also sometimes called orogenic rainfall. We get this term from the Greek oros, meaning mountain. This occurs when moist wind is forced to rise over mountain or other elevation in the path. Thus, the windward sides of many mountain ranges receive heavy precipitation, whereas the leeward sides along which the air moves down receives less rainfall. Such situation occurs widely along the western coast of India. Cyclonic rainfall. This type of rainfall is associated with the passage of a cyclone or a depression. There are two types of cyclones, the tropical cyclones and the temperate cyclones. The term cyclone is derived from the Greek word kyklon, meaning revolving.
మా వీడియో గనుక మీకు నచ్చినట్లయితే లైక్ చేయండి, షేర్ చేయండి. ఇలాంటి మరిన్ని వీడియోస్ కోసం మా ఛానల్ని సబ్స్క్రైబ్ చేసుకోవడం మాత్రం మర్చిపోకండి. థ్యాంక్ యూ ఫర్ వాచింగ్.